Hi guys, we'll be presenting the Invisibility Cloak and catching the Snitch. Hi, I'm Nayan.
Hi, I'm Nalanchi.
So the goal is to build an invisibility cloak with a little bit of AR. So as a part of this demo, we'll first look at how to build an invisibility cloak and with some additional AR. For people that aren't familiar with an invisibility cloak, yes, it is the cloak that makes Harry Potter invisible. We've also included a small GIF to the side, which outlines the effect in case you're not a Potterhead. The technique can be considered to be the opposite of green screening. In green screening, we remove the background, but over here, we will be removing the foreground frame. To supplement this, we have a catching the snitch experiment, where we experiment with the concept of augmented reality using OpenCV and OpenGL to manipulate a 3D spinning cube using our hand gestures. So, what is the approach that we took to build the invisibility cloak? So, first we record and store the background frame. Next, we detect the color, which will be similar to the cloak that you're using. And we detect this color using segmentation and color detection. After this, we segment the color out using this mask and replace this colored portion with the background image. And voila, um, so how did we build this? So first, we replaced the red colored pixels if your cloak is red. So you're replacing the color with the background pixels to create the invisibility effect. To do this, we have to store the background image for each frame. We do this by recording the background image. In our case, we did it roughly for 1.5 seconds. Next, we try to convert the color space to HSV, and we do this because RGB is really sensitive to illumination. And now we can detect the range of the color that we have in place using in range, and we have a mask set up. So with the mask, we perform open and dilation, and we create an inverted mask to segment out this color from the frame. And now we can create an image with the background frames in the pixels instead of this masked region. So some of the challenges and next steps. The algorithm was a bit finicky when it came to the lighting in the room. Um, our in range for the red sometimes detected hues of red on the face. So as you can see in the second image, this was done at night, so we possibly think that the lack of light in the room caused our algorithm to think of it to be a different color. If you see Nilanshi's second image in this frame, this does not happen when we try out the algorithm in the morning. We also tried out blue, and blue does not do the facial finicky thing, which is again because blue is not a color that we think that can be detected on the face. Um, so we do want to explore incorporating varying shades of blue and try to change the color range so that we can remove these patches that you can see in the first image and like a little bit in the second and third image, irrespective of the lighting conditions. So we've spoken a lot about what we did. Uh, this is a quick demo of how it went about. Um, so in the first one, I try on like a blue T-shirt. As you can see, we try this out at night. This does not have the face pixel thing uh, that happens. This is Nilanshi trying out a red cloak at night. This did like performed way better than the first one. There's just a like a few pixels missing from her face, and as you can see, it's like it's done beautifully. You can barely see her in the frame. This is Nalansh testing it out in the morning, and now you can see with better lighting in the room, the pixels on her face are not disappearing now. So, so this is really cool, and we were really happy with the results that we saw with this algorithm. This is just us fooling around a bit with the invisibility cloak because why not? Just
Yeah, so the second part that we implemented was catching the snitch. And snitch is like a small flying golden ball used in this fictional game of Quidditch in Harry Potter again, where wizards and witches fly on flying broomsticks and try to catch the snitch, and it's really hard to get. But yeah, let's talk about the algorithm. So we use gesture recognition and augmented reality, like very basic of it, for our application. So what we do here is we take a screenshot from the camera, like the webcam, and inspect it for gestures. So if one particular kind of gesture is recognized, then we blend and render a 3D object like on the screen. And if another sort of gesture is recognized, then we stop rendering that object, which is like to give the effect of, magic happening with your gestures. So yeah. So our approach for gesture recognition was that first we initialize camera and detection function. So what camera, like webcam function, does is it updates frames and calls detection functions every few seconds. So in detection, what we do is we specify a rectangular frame size in which the algorithm looks for a gesture. So it's like if your gesture, or which is face or hand, anything, if it's too far or if it's too near, then it might not be detected. We're doing this for efficiency purposes. And next we try to, oh, can we go back to the previous slide? Yeah. And so the frame looks throughout the image, and there's a scene drawing function which redraws the frame. Now if something is detected, then we do it, then we move the sliding window locally, otherwise we do it all over the image. We use OpenCV higher cascade files for detecting frontal face and hand wave gesture recognition. So these are XML files which are trained on different gestures, based on edge features, line features, and they are all integrated. So we use the defaults one here to do our task. Yeah. So we use OpenGL, which does loading and binding texture for a 3D object. So what we do is we have a picture of a snitch and we stitch it in a way that it becomes a cube, and then we blend the cube to make it transparent. So like the black pixels from the images are removed, and it looks like a transparent 3D object, so as to give the augmented reality or 3D effect. And what we do is we draw a cube on top of the background. So we have Z coordinates in our visual like display also. So the Z coordinate for the cube is much forward and the background is much backward, so it does not look like a 2D animation but really looks like a 3D augmented reality effect. So challenges that we faced during doing this was determining the position of rendering, background, and cube coordinates. So just rotating the cube, putting the cube, and adjusting it with respect to the background was a little difficult, such that it would not block everything but also be clearly visible. And to combine the gesture recognition and AR modules, like detecting it and at the same time rendering the cube, it was a little difficult, but we managed to do it. Some future work would be to train our own hard cascade files, that is our own gesture recognition, maybe something like OP or any other gesture recognition which is not there in OpenCV by default, and also to try more 3D objects and live positioning. So right now the cube is just seen like at a particular position like near the face, but maybe it would be really great to see it like live wherever your face is. So yeah, the demo, we had two gesture recognitions, like one was face recognition. So if the algorithm detects a face, then it would show the snitch, and if you wave your hand, then the snitch goes away. So waving would, any hand would do left or right. So if you wave, you can see that the, like, if it detects a wave, the snitch goes away, and as soon as it detects my face again, the snitch comes. And if you do a fist, then it doesn't really do anything because it requires a wave, which was great, like the precision was good, and so you can't really catch the snitch, but as you can see, it does the effect. So thank you.